Where are you guys from?
St. John's.
Okay. Alright, so the first thing we want you guys to do is show us probably your 2 favorite programs to run. The 2 that either you think are the most creative, or that you do most reliably or best, or one that, you know, is a particular challenge for you guys.
It's a big attachment.
Yeah. We need a bigger one.
No, we didn't.
You're already so.
You guys use any sensors when you, on your robot? Yep.
We use the rotation sensor.
Rotation sensor?
You ready?
That's got me stuck.
Yeah, it's stuck.
It's a big thing to move.
Yeah.
It's like the drill.
What made you, how did you come up with this design for the attachment?
We saw one team from the other competition use it, and we saw it was successful, so we wanted to try it.
Yep.
And also to add on to his answer, we saw that theirs wouldn't work and our other one wasn't always successful. A lot of times it knocked the polar bear over the side, and so we didn't get any points for that. And one time it broke the...
What are the challenges of going overhand as opposed to then laying it down?
Like you saw, it probably gets caught with that. And that's basically our only problem with that. That thing gets caught.
Having it accidentally throw too far, or putting it down, the arm down too fast, and throwing it over the table.
How about this initial part? Is that there for most of the other ones? Is that your base attachment?
That's really our base attachment. That we kind of started out working on the carbon mission, and then we just expanded and did all the other missions from it. And the angled inwards on the outer side is to try to keep the balls inside of it.
It looks, what made you decide the distance? It looks wide.
It was so if like we got off a little bit on the carbon, it would still like go in.
Oh, okay.
How many of the missions do you guys try to complete? Yep.
Well, on a few missions, like the one that you saw, we try to get a few things in Glacier, or try to get the carbon dioxide and the buoy at the same time. And on the first mission that we do, we have an attachment that brings one of these blue people to the mountains, and then it grabs the insulation in the bike and brings it to the house.
Okay.
How'd you solve the arrow problem?
When we built, well, we just had to raise this the whole way up, and we went out and we just basically went over here, backed up, and that would hit it and push it.
How do you figure out how many times to hit it? How did you program that?
We just program it to do once.
So you'll run the robot all the way out if you have to move it twice, for example? So you get the robot there, take it back twice, and then bring it again?
And we had other missions connected to it, too.
Okay. So if you have to move this 2 times...
We let the other team do it.
Okay. Yep.
Yeah, we wouldn't, like if it was only once, we'd only do that if it was, like, we'd only do it if it was once, because we only have like 3 minutes to do the whole thing.
Yep.
Because in our previous competition that we just had, our table, we didn't touch find agreement at all. We barely went over there, and the other team went ahead and did it. And that's sometimes how we rely on the other team to get us those points.
So you use the other table to help you guys, and you assume that they're going to spin it once maybe, or?
Yeah.
Okay.
And actually, right before we came here, that team, before we started, asked us if we were going to do the find agreement, and we said no, and they did it for us.
Okay.
Interesting. Innovative.
Good use of teamwork. So, how did you come about the design for that? I mean, did all of you guys work together on that? Did a couple people get assigned the task?
Well, we kind of split up into small groups, and then we had 4 different robots to start off with. And so each group had a different robot to build on. And so basically we chose the pros and cons of everybody's features and kind of added them onto the robot.
Okay.
How did your coaches and parents help?
We made a My Block, and we had our mentor, Mr. Ritchie, help us with that.
What were you going to say?
I was going to say that.
Oh, okay.
Well, our parents had to bring us to and from every practice, which was for 2 hours on Mondays and Wednesdays. So that was kind of a time commitment for them. And our mentors just kind of guided us through it and helped us figure out exactly what we needed to do in each mission.
What role did you play? What did you work on?
I worked on building and programming.
Was it fun?
Yes.
Is this everybody's first year or second year? Or?
Some are second, third, and
First.
some are
A
first.
lot of people,
Most are
first. Yeah.
3 minutes.
Did I see you've got a printout of the program? Can we look at that?
Can you try another mission?
Yeah.
That's the carbon and the ice blue mission.
You want to explain them then?
How are we doing?
Carbon. Guys, don't lean on the table.
If you want to hand back the...
What would you do differently now that, like for next year, let's say, what would you change for next year if you had the same kind of a task?
Well, what I think we would change is probably try to make the robot, like, make more like My Blocks and stuff to try to make it more accurate. And so it works a lot better. Because some of the missions, like, they work well at RMAT, but they don't work well here.
But what's the biggest problem you guys have had here? Yeah.
Well, really it was alignment. When we were out on the practice tables, the board actually wouldn't let us align up with the jigs for our alignment points. The board wasn't allowing us to line up, so every mission was off just that little bit.
When we were turning, sometimes the turning would be too wide, so we fixed that problem by using a My Block.
Okay.
Run it.
Yep, go for it.
That's off.
Yeah, I noticed it was off as soon as it started.
Guys, it looks like we're about out of time, so thank you very much. Good luck with the rest of your day, and hope you guys are all having fun.
See you next year.
All right.
Thank you.
Thank you.
Thank you.
Thank you.
Okay.